Hello, everyone. Let's continue working on some geometric problems using the quadratic equation so that we can solve for an unknown. So in this first exercise, we were given a triangle, and because we have this box, we know it's a right triangle. Because we have these two tick marks, we know that it's an isosceles triangle. So we have an isosceles right triangle whose area is 50 square feet. So think about the formula for the area of a triangle. And if you thought 1/2 base times height, then you would be correct. So we were given that the area is 50 square feet. Now we're just going to substitute what we know. Since it's an isosceles triangle, both the base and the height can be h, as that is the unknown that we're using here. So we have 1/2 h times h is equal to 50. And now we just need to solve this equation. To get rid of that half, we're going to multiply both sides by its inverse, which is multiplying by 2. Okay, so when you multiply by 2, you can see that the 2 in the left-hand side cancels with the half, and 50 times 2 is 100. So we're left with h squared is equal to 100. Now we said that whenever we're solving for an unknown, we're going to do the inverse operations. So the inverse of squaring is to take the square root. And since we have to take the square root of both sides, we are left with wondering what number times itself, 2 times, will give us 100. So I know that negative 10 times negative 10 is positive 100. Positive 10 times positive 10 is positive 100. So there are 2 possible solutions. However, we're going to always reject the negative solution when we're dealing with geometric shapes because we cannot have a negative length. So the height is equal to 10 feet. Okay? You have solved these problems before, but you never had to write plus or minus 10, is what I'm assuming, if you have not done Algebra 1 before. So this is just a formal solution. We know that if I multiply two negatives, I'm always going to get to a positive. So this is the reason why we need to write both solutions. But when we're dealing with a geometric shape, we're going to reject the negative solution. All right, let's try another exercise. Here we have this geometric figure, and based on this tick marks, I can see that I have a square because I have 4 congruent sides. And we were given an area of 72 square meters and a variable of x. So how do we find the area of a square? Well, it's basically the same as the area of a rectangle, base times height. And we know that all the sides are going to be the same, so the side squared is going to just be x squared is equal to 72. Just like the previous problem, we're going to take the square root of both sides, but this time 72 is not a perfect square. So we need to find the factors of 72, and what we're looking for is a perfect squared. So if I divide 72 by 2, I get 36. Well, that's convenient because 36 is a perfect square. What number times itself gives us 36? 6. So the square root of 36 times 2 is going to be plus or minus 6 square root 2. And just like before, we're going to reject the negative solution. So the final answer is that this squared has a length of 6 root 2 meters. So 6 times square root of 2. Okay, let's try another example. This time we're going to use the Pythagorean theorem. Okay, so we were given this quadrilateral and we were given a length, uh, not a length, we were given that this angle, this interior angle is 90 degrees. This length is x, so that's what we're looking for. This other side of the quadrilateral measures 17 units, and then this diagonal measures 34 units. So what does the Pythagorean theorem tells us to do? It tells us to square the legs, add them up, and set them equal to the square of the hypotenuse. So let's set this up. X squared plus 17 squared is equal to 34 squared. Okay, 17 squared is 289. 34 squared is 1156. Okay, and these you can just do in the calculator. I don't expect you to memorize 34 times 34, or you can always do it on a piece of paper. Okay, so what do we need to do? We need to solve for x. So the first step is to move that 289 from the left-hand side so that we can get rid of it. And to get rid of it, we're going to subtract. So we subtract 289 from both sides. And that leaves us with x squared is equal to 867. Okay, 867 is close to 900. So 900, the square root of 900 would be 30. So I know that 867 is not going to have a perfect square. So I need to look for factors. And it's not an even number, so I won't bother dividing by 2 to figure out if we can find a factor that's a perfect square. However, let's divide by 3. Well, when we divide by 3, we get 289 times 3, and the square root of 289 is 17. So I didn't write it down over here, but 867, the factors are 289 times 3. Okay, and once again, we're going to reject the negative solution. So we have x is equal to 17 times square root of 3 units as the length of this side of the triangle. Okay, I hope you found this helpful.